Okay, cool. So your question was just about like, are there better tools to help sorting? And that is possible. Although I think it's hit or miss basically. So I'm going to share this file first, which is a tool called lpips. And lpips essentially tries to do what we're describing, which is that it uses a neural network to try and figure out how close images are um, to each other, essentially. I also have a video on YouTube about how to use this that I will find during our break, and I'll add that as well. Um, so this essentially uses, I think it uses like VGG or one of those sort of uh, basically trained neural nets that we've talked about, and it tries to go through the layers to figure out how images are represented. What I have generally found is that it looks at basic structures and it can sort of say like, so to use Dakota's example, it'll be able to tell if a bowl is like aligned in the same way. A soup bowl is aligned in the same way, but it won't really be able to tell like, oh, there's a leaf of the soup in the same place. So it can be a bit of a challenge for that. So it's not perfect. The other option, and I was again talking to some people in the co-working session about this, is we talked a little bit about this tool called Clip, which is CLIP. Um, I don't, do I have it open here on my desktop? I usually have like 1,000 files open on my desktop, but I cleaned it up. Oh, I do. Okay. Let me share this one as well. So Clip is what it does. You can feed it like some labels, some like basic text descriptions, and it will try to figure out which of those fall into which category. So let me share my screen real quick, and I can sort of show this. I am still working through the best way to actually use this tool because it's a little funky. Um, it's just not set up to really like by default sort things. You guys can see this notebook, is that right? It says clip face discrimination. Cool. Okay. Um, so what this does is you feed it labels. So in this case, they've sort of fed some labels for objects that I think might be in these photos in these rooms, and then it sort of says, yes, I bet there's a chair in this room, or yes, I bet there's a watch in this room, and it gives a sort of predictability score. And you'll see here, like it's not perfect, but this could be. So one thing I was talking with a former student of mine, and he has a bunch of furniture, and he only wants furniture that's on a white background. So this is a cool thing where you could basically say like furniture on black background, furniture on white background, furniture on, I don't know, a colored background. You could then you could feed a bunch of images through Clip, and it could then score each of those images based on what it thinks is there. So this could be another tool to use. I actually have only really briefly started using this, but I think there's some potential here. I need to go through and actually build a notebook that would actually do the sorting process, but there is a way to get a predicted score from these things using a piece of text. So I think that has some potential opportunities and could be a really cool tool to use. But yeah, it's bulk sorting is always a hard thing. I think in the data set class I taught previously that I think Steven was a part of, I also walked through a demo of creating your own object detector. So basically I did a thing where I like just you feed it, you basically build a bunch of scored or like samples where I was saying like here's a cat face, and then I fed it through. You train the object detector to find every cat face, and then you feed it a bunch of photos of cats, and it tries to find the face around it. So that's another thing is that you also want to think about like how the image is cropped, right? So what this did is it allowed me to sort of like always crop the same way in a bunch of images of cats. So those are other tools that you could use. I will try to find the links to those as well, and I'll post them in our chat during the break. So yeah, there's a bunch of things you could use. It just depends on how much time you have and how much you want to invest in making a quote unquote perfect data set. For this class, I would generally recommend just try what you have and see what happens. And if you find that the results are bad or you just don't like them, then you might want to invest more time into sort of like creating a better, cleaner data set. So this is kind of what the process of like real machine learning researchers do as well, is they scrape a bunch of data, they try to see if their results are good enough as is, but they might need to go ahead and clean their data, whether that's clean up images or whether that's actually cleaning up a bunch of database tables, those sort of things. So yeah, it's a tricky place to work, but there are some tools out there. You're just generally going to spend a lot more time sort of operating on them. Other questions? Other thoughts?
Yeah, the sorting was the most time consuming for me as well. I just ended up kind of using Finder and organizing things and removing things of like really low file size. I thought about using some other piece of software, another app to kind of see if I could like fly through thumbnails quicker. And I ended up just using the Finder carousel view. Um, what what what's your process, Derek, when you're going through like a bulk data set that's been scraped?
It's the same way. I mean, that's I'm starting to look at some of these tools to hopefully fix that a little bit or to narrow my results a little bit, but it's a lot of the same stuff. I mean, it's really just going through and even after I would say even if this clip thing works well, I would still go through every single image by hand. It just is like that's the process. Um, the
But how
hope
do you
is, sorry, go ahead.
how do you set up your like even down to like how are you setting up your desktop or like what's your view to like if you load a image a file sometimes there's 25 megs it's not
Yeah.
that fast.
Yeah, that's a great question. I can actually just share what my data set folders look like. So uh, so again, I also have a lot of data sets. So this is a 5 terabyte drive that I just carry around with me everywhere. And inside of here, I just break everything down into categories. So see, I've got like some artists, like particular artist works. I've got birds, fish, florals, patterns. And then here, it's just like a bunch of individual image folders from here. I tend to use this view because it only loads up a thumbnail. And also I should say like, I generally do this work on my local desktop, which is much faster. And then when I'm like cleaned it up, I'll move it into my hard drive because this is, as you can see, it's loading forever. But this is a 160 megabyte file. Most of these are scans from books. So that's another thing is like, uh, it's sort of like, do you want to do the cleanup before you get your data or after? And for me, it's like scanning books means I have a much cleaner data set coming in, but I have to do the manual work of getting it in. But I'll generally use this view, which is pretty fast because it's just that smaller thumbnail view. And I'll just like really I'll like put music on and then I'll just like tap through each image and like you just get in the zone of like tap, delete, tap, delete, tap, delete. Learning all the key commands for deleting stuff is also really key. It makes everything move a lot quicker. So I should also say like, so usually like I'll do a process of just downloading stuff in bulk. Those go into a folder that is usually called like raw or some sort of like bulk download process. And then you'll see like these are literally the folders I use in dataset tools. So I've got a tool that does, um, so if you look at some of these images, a lot of the images that I get from books tend to have borders on them. So I built a tool into dataset tools that actually crops into like the closest piece of art. So I'll generally run that. That's this thing called crops. Um, that is its own cleanup process, so it's like also rather time consuming. And then I will like basically build up a bunch of folders that manage all of these pieces. So I know Mei Lee was asking about just like how do you manage this stuff? Sometimes I know that like, oh, crops are like something I'll reuse often, so I'll keep that folder. Other times I'm going into intermediary steps, right? I might be like stretching something, or I might be a common thing I do is I'll add bright green, like when 255 green borders to things. And then I've got a script in Photoshop that will use the context aware fill tool to sort of fill in those borders so I still get square images. That works with varying success. So those folders I'll usually delete once I'm like through that half process. So it's kind of I get in the groove of like figuring out what I'm going to keep and what I'm not, but it definitely fills up your hard drive very quickly. So it's definitely sort of like why I've got 3 or 4 hard drives that I keep attached to this. So that's really my process, and it's still like I do a lot of manual sorting. Like so, every time I produce one of these cropped images, there's usually a folder here, and I haven't really ever. I don't think I've documented this tool because it's probably only me using this because it's like a very narrow use case. If anyone wants this document, I'm happy to. But like literally in meetings where I like don't need to be my full attention. Hope no one from my office is listening to this. But like I'm literally just like in a meeting where it's just a check-in. Like I'm just going through here and I'm like cleaning stuff up. Like okay, yep, that's a client. That's a fine image. Um, this boxes thing helps me make sure that it's like fully encapsulating the box I need. So yeah, this is pretty much what I do every day. Like I literally never stop doing this, basically. Um, so it's time consuming. It is super time consuming, and the hope is that it like eventually pays off. Which is why I would say like for most people in this course, like just having at it, just playing with it is totally fine.
Are you using color tags to then go back later and pull them? Because like oftentimes if you pull and drag something, you'll lose your spot in like a long list of 500 files.
Sometimes, yeah, like I mean, yeah, sometimes I will just tag like I'll do something like a green and that's the last place I stopped or something.
Mm.
You'll also see that I've color coded my folders here as like these might need more Photoshop work or other things I need to go back and fix. Um, I have also this crazy complicated undocumented part of the dataset tools library that can also sort by these MAC color tags. So like if I tag a bunch of stuff red, I can just like skip those when I do a process. Because sometimes with a lot of these, I've got 1,000 images and like 50 of them are tagged red, and I just want to like start training something, so I'll just skip those and like move and like use my other data. So there's like I have a whole crazy system for this stuff. And I also like recommend that you just like set up your own system. Whatever works for you is going to be better than like trying to stick to someone else's process. But yeah, it is very intense.
I have another question, but I don't know, like something to share with eventually questions inside of it, I guess. But the I've been looking into just things like either apps or software that could help like color sort.
Mhm.
But I haven't gotten this running, and
Yeah. Uh, yeah, Raster Fairy is a cool tool. I also don't. I think that uses. It might use like some other VGG stuff or other like tools. I think he's updated to include some AI tools. Another thing I've seen a lot of people use is I believe Google Photos has like some built-in classification tools. You know how your iPhone like is like, oh, this looks like a bunch of people, or this looks like, location based or that sort of thing. A lot of those tools can be used too. I've never really dug into those too much because I tend to work with more abstract stuff, so I find that like Google Photos doesn't really work well with abstraction. Like it'll just say everything's a flower, and I'm like, that's cool, but that's not exactly what I need to know. Which is why I think stuff like Clip, which is a little bit potentially more open-ended, might be a cool tool to start to use. So maybe this week, hopefully this week, I could maybe get to building a notebook for that if anyone wants to try it, and we could see how that works with everyone's work. But yeah, there's a ton of tools out there. It's just all like how much time do you want to invest in playing with them, learning how they work? Most of this stuff is undocumented, right? Like I'm sure like uh, Mario probably hasn't documented most of this stuff in years. It's like his own personal tool. And that's sort of true of my dataset tools library as well, as there's a bunch of undocumented stuff in there. But if you're interested in it, I'm happy to document it. Just more like, well, I'll like work on the stuff that I know people need, and then until I know someone needs it, I'm not going to document it. I'll also give another shout out to the dataset tools class that Leah and I taught in last fall. I know we linked to that. This is one of those things where like I will throw many 1,000 links at you, and you probably won't realize they're helpful until it's too late. But we went through a bunch of different tools and materials in that class. So if you are interested in diving deeper into this whole subject, that was like a 4-week class, and there's a lot of good little tips in there. So maybe like put them on and put them at 1.5 speed while you're working in the background or something and see if anything jumps out at you.
Do all of the models require same size? That was something that we were chatting about, same size images.
That's a great question. So Munit and CycleGAN do not require same size images. StyleGAN requires the exact same size image down to the pixel. And for this course, I'm going to recommend you keep them square. Doing non-square stuff is a pain in the ass. So I would recommend 512 or 1024. For next stream prediction, we'll probably talk about this when we go through the demo. It has some light requirements, but not too much. It's like it has to be 32 pixels, divisible by 32 on both dimensions. Usually that means it's like 1280 by 720, or I guess 1280 by 736 or something. There's ways to fidget with it a little bit, but that's a way to work with it. And then for style transfer, there's no requirement on dimensions. So we'll look at that again today, and there's There's usually limits. There's like usually an upper limit. Like if you try to generate an image that's over like 1200 pixels, it'll probably crash the GPU or it'll just like throw an error. But there's no requirement on dimension or anything else.
Cool, thanks.
Okay, so we are already halfway through class. Okay, so why don't we do this? So why don't we take a quickish, like let's say 7-minute break or whatever, like let's say 6-minute break, and then we'll come back and jump into next stream prediction. So we'll see everyone at 15 after. All right, so I can tell already that we're gonna push our time here. So I think what I'll do is for the style transfer work, I'm just going to kind of show some tips and tricks because I think people have done style transfer before. So I'm gonna let Leah do the next stream prediction stuff, and then when we get to my section, I'll like condense it a little bit. And if people want more help, we can always do it over Slack.
Sure, that sounds good. Should I still do the training on Colab slides pretty quick?
I think probably just because it's going to help explain next stream prediction or how we use it.
Cool. All right. I'm a little blurry. Yeah, so today we're gonna start talking about how to train models on Colab. There's a general common workflow with training on Colab, which I'll go through shortly. Essentially, the gist of it is that like when you're doing training, which can take, you know, usually like on the order of hours or like days or weeks, Google Drive or Google Colab has a particular session length that, you know, you get cut off after like 20 hours for Colab Pro, for example. So there's a particular trick to, you know, be ready to like lose your files at any moment in Google Colab. And the solution to that is Google Drive. So as you all know, when you've been working with Google Colab thus far, like running inference or using like the Colab notebooks that we've showed you during I think the second class we went over Colab, you usually have, you know, Google's nice beefy GPUs. Usually at the beginning, you have a couple cells to install some dependencies or libraries. Usually they're like cells that start with pip install something. Your Git repo, which is, you know, usually like maybe for Stallion, the Stallion 2 repo. And then your files, like images you've uploaded or things like basically like assets that you have uploaded for using in your session. So that's like the usual setup. Everything's just on your Colab server. The problem when you move on to training is that training can often produce really, really big models. And Google Colab itself has a limited hard disk space. With Pro, you get about 50 gigs. And next frame prediction, training next frame prediction models, each model can produce about, or each epic can produce about 750 megabytes per epic. So you'll very quickly, you may run out of storage space on Colab itself. So yeah, like I said, usually, you know, everything's just on your server hard drive in Colab. But if you're doing training, the way to get around this is to use Google Drive. What that looks like is mounting your Google Drive account and basically saving your training status all directly into Google Drive. So that means like even if your internet cuts out or Google Colab decides to like cut you off after 20 hours of training, all the files will still be there in your Google Drive and you can just pick back up where you left off. Whereas if you don't have them stored in the cloud, you know, everything's just in your Colab session and it'll go poof as soon as you get cut off. So, you know, these things that used to all be on the Colab server, we're actually splitting them and putting the Git repo and any files, any checkpoints or models that have been created during the training process onto Google Drive. So essentially it's kind of like, you know, like video game save checkpoints, they're all being like saved to Google Drive so you can pick back up where you left off in case like whatever happens. So yeah, an analogy for that is like Google Drive is virtual storage for Colab. What that means is like you can write to it, like store files on it without it like taking up your Colab hard disk space, but it's essentially accessible pretty much in the exact same way as things that are actually physically stored on your Colab hard drive. So yeah, we are just splitting our disk storage between Google Colab and Google Drive and putting, you know, all of our training status on Google Drive so we can pick back up where we left off if we get cut out. Cool. Any questions about that? Okay. Well, the first demo of today is next frame prediction. This is a model that you just need like a very short video to train. Like Derek said, like 5 or 10 seconds is enough to train. So often, like you start off with your short little video, it gets cut up into frames. And as we've mentioned before, next frame prediction is a type of a pix to pix model. So, you know, one picture and they're in pairs, and it's converting from this picture to this picture and this one to that one. And what makes next frame prediction like next frame prediction is that, you know, it starts with frame 1 and then tries to predict like frame 1 to frame 2, how do I do that? Frame 2 to frame 3, how do I do that? And so on until all the pairs have been trained. So after you've, you know, gone through and done the training, what happens is you have your model, your next frame prediction model that's trained, and it essentially like you start off at a certain frame that you give it, and then it just predicts what the next frame is. And then from its predicted frame, it predicts what the next frame is, and so on. So generally the results you get with this is that the video tends to, you know, sort of drift and get kind of more and more amorphous and like over time because it keeps on aggregating, like going off of its last prediction. So yeah, the Collab notebook is here. I'll give you a couple quick examples of next frame prediction. I'm going to share my entire screen so you can see everything. So this is the video I'll show the demo for. This is the original source video on the right. So just this pixel sort that I did of like, you know, these colors and stuff. And all the way throughout, it's just this linear motion. And this is the output of next frame prediction, is that it starts getting like these very blobby amorphous textures as it goes on. A couple other examples. This one is a piece by Kishiyuma done on a woman's face. I'll show some of Derek's too so you can get a quick idea of next frame prediction. Next frame prediction, more next frame prediction. Yeah, so you get the idea. The notebook itself is linked in the slides. This is what the notebook looks like. It essentially starts off with, like always, mounting your Google Drive. Oops. Like I mentioned, it's the reason why we mount our Google Drive is so that we can sort of store all of our training status in Google Drive in case anything happens, we can pick back up right where we left off. Okay, there we go. So my Google Drive is mounted. All of my files from Google Drive are here. You can check which GPU you're assigned. Sometimes it's helpful to know so you can estimate like if you got a worse off GPU, that training might take a little longer. so you can estimate that. This cell will install the GitHub repo, the Pix2Pix GitHub repo, and it will create, like we said, it'll create the repository in your Google Drive. So in my drive, I now have this folder called NFP Collab, and it contains this entire GitHub repo of the Pix2Pix HD. Then in this cell, you just upload your video. So here I have uploaded that source video that I showed you, this one. I just dropped it in my Google Drive and then grabbed the path to it and put it right here. So that's how you input your source video. You give it a name. I just called mine ChromoSen, and input the width and height of your video. Like Derek mentioned, the restrictions of next run prediction, because of just some details about the model, is that the width and height have to be multiples of 32 pixels. So this one's fine. It's 1280 by 1280. Often you might have 1280 by 720. But yeah, just input your video, call it a name, put in the width and height in pixels, and make sure they're multiples of 32. Running this will go ahead and cut up that video into frames so that it can just do the pair-to-pair training. This one I have already done, which is why it is erroring out. But yeah, when you run this, it'll just split your video into frames. And then down here, this is the place where training begins. This notebook is pretty straightforward. You just kind of run through the cells like bang, bang, bang. And this is, the key cell where you input your training video. But yeah, in this cell starts off training. Input the same name as before, as your name, your dataset name. And here you can specify how frequently you want a checkpoint or like a model saved out to be like, okay, I'm gonna save my status right now. So the way this is saved or written is that every 5 epochs, it's gonna go ahead and save a checkpoint. So I could pick back up from epoch 5, 10, 15, 20, and so on. So after clicking this, it will start, spitting all this stuff out and telling you that, is there any reason why you wouldn't always be saved by 1 epoch? My guess would just be storage space. If if you have a lot of storage space, I don't think it would matter that much. It might just take a little bit of latency to go and save that. I don't think it would add that much time. The thing is that, if you are saving every epoch, you might end up with 20 different models you want to review later on. And the difference between epoch 1 and epoch 2 might not be a lot, but the difference between epoch 5 and 10, or 10 and 20, might be salient enough that you can be like, oh yeah, I definitely do like the outputs of model 20 more than model 15. So yeah, after starting training, you just sort of, set your computer and let it run for, overnight or several hours. Just for an estimate, the source video I probably should have used a shorter video. It was about 25 seconds long, and each epoch took 3,400 seconds, which is about an hour. But if you use a shorter video, it'll go much faster. So yeah, I let this run overnight, and it got up to about 20 epochs. And then once it is trained, you can come down here to generate the video. And yeah, essentially just replace the name with the same name you used before. And then here you can specify how many frames you want it to generate and how much what FPS video you want it to output. So this will be 600 frames at 24 FPS, which I think is about 30 seconds. And here with the epochs we were saving out earlier, here, this parameter here, if you have it as which epoch latest, it'll just grab your latest. So in my case, it would grab epoch 21. If I specifically wanted like to try epoch 10, I would just put 10 in there and then use that to generate the video from epoch 10. And then, yeah, just clicking this will start generating the video. It might take about 5 minutes to generate, and then it will be available in this checkpoints folder, NFP, Colab, Pix2Pix HD. I went to it in my Google Drive just because it's easier to see here. But yeah, checkpoints, name of your data set, chromosome, output, and then these output videos. I'll go ahead and show them. I did it for epoch 5 and epoch like 25, I believe, so you can see the difference. Let me pull those up. So the one on the bottom, here, I'll put them side to side actually. They'll be slightly different. This one on the left is epoch 5, as you can see in the file name, and the one on the right is epoch latest, which I think was number 25. So I'll just start these at the same time. We can see the difference. Yeah, just like slight variations in it. The difference between these two was about like 15 hours of training. As you can see, like on the right, we're getting these little flippy dot things like here, like these dots, which aren't appearing on the epoch 5, the earlier one. Yeah, so that is how you train a model and then generate the videos. And if you want to just pick back up training, because I don't know, it cut out at epoch 21 and you were like, you decided you wanted to train for longer. All you have to do is you come down to this cell, input, your data set name, the save epoch frequency. Here we have it as every one, like David Allen suggested. And then, yeah, that's pretty much all you have to change. And then it'll just pick back up where it left off. Cool. Derek linked a example folder of videos every 25 epochs. So y'all can see like the difference as you go from different epoch to epoch in terms of next frame prediction. Any questions about that?
Yeah, so also add, you can train it. So by default, it stops at 200 epochs. If you want to train for longer than that, you can. You just need to make some edits to your training command. So if anyone's interested in that, I'll add the stuff you need for that. Unless Leah, do you just want to add it to that notebook real quick?
Sure.
So it's just in that continue train. There is here. I'll just type it in our notes here. Oh, this never works. 1 second. Essentially, what you need to add to that continue train is you'll do if you add these two commands. This will train for 400 total epochs. So basically, you add these two numbers together. So by default, it's 100 and 100. There's just a little code that basically there's like a decay rate on the learning rate, which we don't need to get into. But basically, this is how you do train it for longer. And I do know some people who train their models for very, very long periods of time, like 1,000 epochs. And it does almost reach a point where it almost repeats the video back to you. So the longer you train, the better it will get. But if you want to train for a week, you can. But most people don't. Most people kind of like the chaos and the sort of glitchiness of training, up to 400 epochs. So I do find that like longer it trains, the more stabilized your video will get. And sometimes it also means, and we'll look at this, I believe, in 2 or 3 weeks. We'll look how to feed it in a different starting frame, and it can feed from that frame. And that will generate different effects and that sort of thing. So we'll look at that once our models are trained. So if you train your model for a really, really long period of time, you can actually feed it a totally different image, and it will sort of like take the motion from another image and like apply that to this to a new image. But you need to train it for quite a while to get that. I tend to find that if you're not training it for weeks, what tends to happen is you feed an image and like very quickly it like dissolves back to the other image. So just beware of that. But yeah, it's a fun thing to play with, but it's pretty chaotic. It is hard to control. I've described it a lot like video feedback. If you ever like saw someone hook up like a video camera to another like video screen or like a CRT monitor, and like you get this like feedback loop system, it's definitely like that. So it's very hard to control, but it is very fun. Any other questions about next-stream prediction?
So do you have to crop your video so that the dimensions, especially the height, is divisible by 32, which is not common?
Yeah, it is not common. What I have found is that you can play with the settings. I think there's a height and width in that setting. I would generally recommend just cropping it or stretching it. Like you could add black bars to the top and bottom of your video to have it match that size. That would probably be the easiest way to make it work.
And that would be altering or prepping the actual file, the asset, not changing parameters, right?
Yeah, that's right.
And then does the training data take up a lot of space on your Google Drive, or just the data set and the generated videos?
The data set doesn't take up too much space just because it's individual like JPEG frames of your video. So unless your video is like 3 minutes long, it's not going to really produce that much data. But it's definitely those model files are really the big beefy, like they're like 700 megabytes for each file.
Right.
Leah, would you mind sharing that, just showing your screen and showing your Google Drive? Because it's also helpful to sort of, if you need to clean up or download stuff, I think you can also do some stuff there. So yeah, so here, actually that folder that you were just in is great.
Yeah, I was wondering whether I need
And
to
the
get a new
checkpoints.
Google account before doing this.
You might want to. So I generally recommend buying like the 2 terabyte, which I think is like $100 a year or something. That's generally a good option. Yeah, you can. Yeah, it's like, yeah, so it's like, I guess it's $100 if you pay for like a yearly plan or something. But if you go in here, you can download these files. So if you'll see the G file is 700 megabytes, and the underscore D file is 21 megabytes. So that is, again, remember if we talk about GANs, the G is the generator and the D is the discriminator. You quite honestly don't need the discriminator file ever. Never delete your latest versions. I would just say like that's the one thing I would never delete, because if you have a latest N and latest net G and latest net D, you can always resume from these files. So I generally recommend like don't delete those, just play it safe and don't. If as you're rendering out videos, you're like, I just straight up don't like this epoch or whatever, you can delete the number that is associated with the epoch. You can also technically delete all of the netd files other than the latest, and you'll be fine, because when you generate video, you don't use the discriminator files, but they're also really small, so it's kind of like not really worth it. But yeah, I would recommend. This is also, again, I think David asked why you would maybe not do every single epoch. This is why, because if you do this for 200 epochs, I don't know, what does that end up being? It ends up being like almost like 1.5 terabytes of video files. So yeah, you might want to choose the epoch count of 5 just to like save yourself space if you know you're going to go toward those later ends. Remember, like the earlier epochs are going to be really chaotic and pretty noisy. Later ones will get a little bit more stabilized, but sometimes you still get really cool effects with them. So it's kind of up to you. I also say like if your video is longer, you can usually train for less epochs because it's cycling through all that data. If you have a short video, you might want to train for longer. Like you'll find that the training time is like a combination of how many epochs you're training it for, as well as how long the video is, as well as how big the video is. You might be able to get away with like 2K, like a 1980, like 1080p kind of video on these GPUs. Might. So you can play with it and sort of figure out. Basically, you just play with it until it says like I can't do this, and then you just scale it back down. Yes, there's a lot of parameters you can play with in terms of the next stream prediction while you do this, and you'll kind of like as you do more of it, you'll kind of get a good like intuitive sense of what's what. Any other questions? All right, let's switch over to style transfer. So I definitely recommend, train a couple videos between now and next week, just to sort of see what you get. One thing to note is you can technically run multiple Colab notebooks at once, but it gets a little hairy with their algorithm and getting off of their systems. So I might recommend that you just buy one Colab, one next stream prediction model at a time, just to be safe. You can sometimes run multiple notebooks, but it definitely will run into issues. Another thing you can do, which is what I as a glutton do, is I have multiple Collab Pro accounts. So you can run multiple files and multiple accounts. When I have a client that's like, hey, I need something by next week, I like spin up like 9 Collab notebooks and my own GPU rig to like make all this stuff happen. Not ideal, but you can do it. If at like $10 a month, it's like kind of a steal. But it's up to you if you want to. If you get really obsessed with this stuff, you will end up doing that. But yeah, there's ways around this if you want to start training more stuff. But in general, it's like one notebook per GPU, and you'll probably want to start by just training on one notebook at a time. All right, so with the remaining 15-ish minutes, let's talk a little about style transfer. I know that everyone has probably done a style transfer, like either through Runway or through one of the notebooks. So instead of focusing on just like exactly what style transfer does, I want to sort of provide some tips on how I can make better images using style transfer. Because you've probably seen like a lot of style transfer work just looks kind of smeary, or it just like adopts colors, but it doesn't do a good job of adopting textures. So I just want to like point you to some tips that I have. So first off, this is the notebook that I tend to use. It's a notebook called Neural Style TF, which is a very particular type of neural style transfer work. I tend to find it produces better images. The downside is that I also tend to find that it is slower than other neural style transfer versions. So again, quality versus speed is kind of a general rule of thumb in machine learning. So you kind of decide what is more preferable for you. So the notebook goes into this, but the most basic is a command is just this, which is just you feed it a content image file and a style image file. There's a bunch of defaults under the hood that like you might have to play with and learn, but there's also a ton of arguments that you can update from here. What I've done in the Collab notebook is it should be one of the better examples of Collab as an educational tool. I've broken out pretty much every single option that you could imagine wanting to use in the style transfer options section. So if you read through this notebook, you can sort of like see one by one what each cell does, how a different argument will change a different parameter, that sort of thing. So I won't be able to go through the entire notebook today, but I do just want to say like there's a bunch more here if you want it. But what I will highlight is just a couple of things that I find tend to produce better images. So there's this thing called max iterations, and what iterations is how many times this image gets run through the machine learning processor, essentially. One thing to note is style transfer doesn't do a thing called training. Like we talked about training in other models, but this particular style style transfer notebook doesn't do training at all. So it actually just runs through a cyclical process, almost like a feedback loop. It processes the image, then takes that image, reprocesses it again and again and again until it generates these sort of stylistically interesting texture transfers. So max iterations determines how many times you do a process. By default, it's 1,000, which I actually find kind of high. So this is an example. I'll just quickly skip through these, but this is what 100 looks like. This is 200, 300, 400, all the way up until, let's see, 800, I guess. So if you look here, you'll see that some of the texture in these details gets a little bit stronger as we go through this. So, when I turn this down, you'll sort of see like these change to a little bit more of a blurriness. And they get really strong, and some of the colors change as well as you go through this. So I definitely recommend playing with max iterations. I personally find that I like my styles around 300 and 400. I find there's a little bit of a loose texture. I find that the longer you run it for, the tighter it becomes. And I tend to find that, like, for me personally, I don't like that look as much. But to each artist their own. But this is the first thing I would play with, is just trying to figure out what the right iteration amount is. The other thing that I highly, highly recommend playing with is style scale. So what this does is actually, the way this process works is it takes the images at the same size, and it transfers the style from your one image to the content of the other image. So the problem is if your styles are at different scales, like if you uploaded different images of different sizes, it might be interpreting those images at sizes you're not aware of. So I actually tend to play with the style scale as a way to scale the amount of style, the image, the style size essentially, up and down. I tend to find that that works much better, and you get a lot better results if you tend to turn your style scale down a little bit. So this is 1.0. This is 0.75. This should be assumed as like a multiplier. So this is 75% of the same image comparison, A to B. 0.5, and then 0.25. So you'll see what's really interesting here is at some point we get to a place where like the particular image I was using as the style image gets so small that the model interprets the style as like little patches of these images. So sometimes you can overdo it, right? Like I would probably say this is overdone. This is like probably pretty good. You'll see it gets blurrier, or like there's less really nice style depending on the scale you're using. So I definitely recommend, this is like the number one thing I do, is I play with the style scale when I'm using these, because I find that you get much crisper styles and much better results depending on what scale you play with. And again, this is all like, what's the look you're going for? You might find that you really like this look. I find this a little too small, but it is sort of up to you what you want to do. There's also a cool thing you can do here, which is called what is this called? I'm blanking on the name. It's essentially a texture transfer. So what you're actually doing is, all you're doing is taking the texture from the style image and generating like a sort of texture mapping of how the machine learning model sees these textures. So this is basically what you do is you tell it to not look at the content of an image at all, just sort of skip it using this content weight command. And then you say to init the image with like random noise, and then it will basically transfer your style onto a random like noisy subject, which is a cool way to make sort of these like nice like weird camouflagey patterns. It's just generally kind of an interesting result. But this also helps you understand that this is sort of how the machine is seeing these style patches. And this is how it's being applied to the image. So sometimes if I just want to do like a debug mode to understand like what style is it actually picking up from the style image, I might use this just to sort of understand like, okay, it's picking up these blobs as the texture, and it's maybe picking up sort of these like streaks as texture. What if I change the scale a little bit to sort of like get different textures? And then another cool thing you can do is you can actually pass in this particular library, you can pass in multiple style images. So in this case, you'll see here what I'm actually passing in are 2 different style images. And you can kind of see that like in certain parts, the black of this image is getting picked up. And in other parts of the image, the red and the blues of this are getting picked up. So what you'll do in this command is you'll pass in the 2 style images. This is actually wrong. You make this, you don't pass in a comma separate, you do space separated. So you pass in each image name with a space, and then you need to apply weights to these. So basically the weight should add to 1.0. So because we have 2 images, we'll split the weight in half. So we'll do 50 and 50. There is another example here of where we weight in opposite directions. So this overweights toward this reddish and blue version and not this one. And you can see that's a little different. I'm seeing it sort of like here, that the texture is a little different. So again, these are all things you sort of play with. This is why style transfer is really cool, but also why it's kind of time consuming, because to narrow in on all the individual results you want takes a little bit of time. Oh, and this is the reverse. So instead of this one weights to the other image, and you can definitely see like the colors are different. One last thing, which I think is another cool effect that I don't see a lot of people use, is you can apply the texture to an image, but then you can go back to your original colors. So using this -- original _ colors command, you can sort of drop the color from your style image and go back to the color of your previous image, which is pretty interesting. I think again, all of these are like tools in your toolbox to play with style transfer. And I find most people don't play with these because, especially if you're using like a tool like Runway, Runway just doesn't support a lot of these things. So this is where notebooks get really powerful and you can play forever with these sort of images. And this is when I do style transfer, this is like generally I spend hours just sort of tweaking little variables to get the perfect image out of it. Cool. So the notebook here, I just want to quickly show a little bit here, which is, so I ran these ahead of time. During images, I'm on a P100 as well, so I'm not on the V100. Each of these takes about, it looks like it took, let's see, but it took about 2 minutes to generate a 512 by 512 image. So, you know, for a demo in this class, it would take up a lot of time. So I went ahead and pre-ran a couple of these cells. So first I ran it with the default. So I used, let's take a look at my images here. Let me just go to my desktop. So I used this as my content image, and I used this as the default style image, and then I also added a second one. So I'll show how to use a second image in a minute. So these get uploaded into particular folders in this notebook. So there is an image input folder. So you want to put your content images in here, and then you'll put your style images in the style folder. So when you run through these cells, it works pretty similarly to what Leah demoed. You'll just run this cell to sort of get everything set up. And once you've got it set up, then there are folders in here that you'll open inside the neural style TF folder. Okay, so I ran this as just like a really basic default. And you'll see, so this is my style image. So this is my content image. This is my style image, and this is what it transferred to. You'll see it's like kind of blurry. There's like some blockiness to it. And part of that is because, you know, I scanned this out of a book and it's a CMYK book. So you get some of this like half toning. So some of that half toning transferred to this. Maybe that's cool, maybe that's not. But the first thing again that I usually play with is I play with the style scale to sort of see what I get in terms of different sizes and different layers. A couple notes here about this notebook, or like as you walk through things, some really important things I recommend. So first is output size. You can change the output size using this --max command. So again, I find that on a 16 gigabyte GPU, which is what a P100 or a V100 is, you can probably get to around 1200 for a max size. Depending on if you have a tall rectangle or a square image, it might be up or down. You'll get a memory error if you crank it up too high. But I tend to find you can get bigger. The bigger the image is, the longer it's going to train, or the longer it's going to take to process. So I think I did this for 1,000, and it ended up, I don't know how long it ended up being. It probably ended up being, you know, 5 minutes, 6 minutes, 7 minutes. So again, it can take some time. A really important thing I recommend playing with as you're doing this is using the folder naming. So at the end of the command, if you add --image _output _dir, that's going to dump everything into a folder that you name. This is a really, really important thing in my work because I want to keep all of these different results. And I might find that as I play with things, like, oh, I like this result, but I want to tweak something. So if you don't pass this in, it'll just keep overwriting the same folder over and over again. So I recommend, you know, being a little bit more careful with how you name stuff and how you do folder names. That way you sort of remember, like, okay, this one was done at 512 and it was for 300 iterations. And maybe if I do something with style scale, I'll change the name out there. So each of these will be output into this folder with the particular folder names. So this is a really nice thing that I recommend doing just to keep track of all your work. And then if you don't care about some of these things, you can just delete them. But I find it's just helpful to sort of keep track of your work there. Another thing to look at are style scale. So style scale is, again, you sort of like build up these commands as you go through this notebook. This is where you can set your style scale variable. So again, 1.0 is the basic same scale of the image, of your style image, 0.75, 0.5, 0.25. And again, I save these out to folders just so I can sort of like look at them. And you could just like I could set up this notebook with a bunch of different options in one cell, run that one cell, and then I would get a bunch of different things out, and I could then go through and look at them. So like, you know, maybe I set up like 10 different commands here, and I let it run, and I come back 20 or 30 minutes later to check on it, and just sort of like then I go through my results and like, oh, I like this one, I don't like this one, I like this one, I don't like this one, that sort of thing. So I ran this ahead of time and I output what the results look like. So this is going from scale 1 to scale 0.25. And as you scroll through here, you'll see, I'm getting different results. Now, personally, I don't love these results. It might be because I don't like the style image. It might be because the content image isn't right. This is another trick, is you just have to play with stuff and sort of find out what works and what doesn't. But I do like that, maybe around here, or maybe the 0.5, I have a little bit more texture inside of all of these images compared to, say, the 1.0, which is up here. So you get a little bit of a nicer, swirly texture. But I would personally play with this a lot more. So just be aware of that, that there will be different options, and you'll sort of spend a lot of time playing around with things to sort of dial in how you want your images to look. And then lastly is the multiple style images. And so this one, remember, we had two different style images. We had this image and we had this image. And if I combine those two, I get something like this. Now, the other thing to remember is that in this particular one, I think I set the style scale. So I set a style scale. So this is style scale 1. So my guess is that if I really want to play with this more, I'm going to need to tweak those values a little bit more. So I might come back up here and just do, let's do -- style scale. And then let's try 0.5. And then just for my own sanity, I want to do scale 0.5. And I'll run this. So I can check to see sort of how this works. So, the challenge of all this stuff is just tweaking endlessly until you dial into the exact right result. And the problem is, because this is kind of a slow notebook, it's you don't get that instant feedback, right? If we were running this on a super fast GPU that had a ton of RAM, I might be able to get almost real time, where I could tweak something and see the results, tweak something, see the results. But it's a little bit challenging in these examples. Maybe in 5 years, actually probably in 2 years, this will almost be real time, and all the endless hours I'll have spent doing this is yeah, exactly. Yeah, it'll be you can do it real time now, but it used to take me days to tweak all these numbers into the right place. Cool. So here's the result at a smaller scale. Better-ish, but I would probably want to play with this more. So that's a really quick demo into the NeuralStyle TF notebook. Yeah, the checker pattern, I think, is actually coming from the content image. Yeah, so it's actually coming from this image. So this is where it might be that the content image is kind of bad for this. Or maybe I need to crank up, maybe I need to do a larger image so that the patches are better. This is kind of one of the challenges. You kind of have to reverse engineer what the machine learning model is doing. So it's just, okay, is the content image bad? Am I saying this parameter is wrong? Do I need to change out style images? Those sort of things. There's a lot to play with in here to sort of dial in. And I quickly threw this together and definitely I think I chose some wrong images personally. Yeah, so there's a lot of things you can tweak within this. And it's fun, but it is very time consuming. So this notebook, if you walk through it, we'll talk about every single detail in here. So if you're interested in seeing original colors being used, you can do this as well. There's even, there's weighting. So this is where we do weighting, texture synthesis, that sort of thing. So there's a lot to play with in this notebook, and it should be fairly well documented. But if there's ever anything that you need confirmed or want to talk about more, this would be a great thing to go through in a co-working session. Any questions? Okay, so homework for next week is, if you haven't finished your data sets yet, I would definitely recommend doing that for next week. So next week we will be looking at Munit as well as StyleGAN. So we'll definitely be covering those then. I think we might need to skip our breakout rooms just to make sure we have enough time, but we'll see where we are. And then, yeah, play around with the pix-to-pix model as well as the style transfer model. And if you do make something cool, please share it in the Slack channel, because I'm sure everyone wants to see what people make. It's kind of the fun part of this class, is seeing what everyone makes out of things. I also recommend sharing them on Instagram or wherever else you share work. You can feel free to tag Lyra and I, and we're always happy to share stuff too. But that's always people are always then asking like, oh, how'd you do that? You know, and then you can be like, oh, I'm taking a machine learning class. I'm like, I know stuff now, you know, that sort of thing. So, yeah. So any other questions before we call it a night? Oh yeah, that's right. Thank you, Maylee. So there's this cool movie, Coded Bias, that I think is gonna be up on Netflix soon. So I'll try to
Yeah,
grab. I'll find the date for it. Yeah.
it might already be out on PBS and it's coming out on Netflix soon.
Cool.
Yeah.
So Coded Bias is a really cool film about sort of like machine learning models and how they are kind of also ruining the world. Thankfully, in the art world, we don't have to worry about some of the more bad parts of machine learning. But if you're interested, I think it's a good movie to watch. It's like 90 minutes. It's like a normal documentary length, but it's very good, very helpful.
The category on PBS Passport is shocking. So I look forward to this.
Oh my God.
I guess
You see
it's
the word shocking going in and out.
It is. It's like preview, and then it's like in theme shocking. So yeah.
cool. Yeah, I'll post links to that as well in our Slack channel. But there's also some other cool materials if you're interested more in the ethical side of machine learning. Leah is a great person to talk about, and then I also have some other materials as well.
Mhm.
Cool. All right. So we'll see everybody next week.
Thank you very much.
right.
Thank you.
Bye, everybody.
Bye bye.
Bye.
Bye.